So today we'll be looking at the observer design pattern. So here is the class diagram of our observer design pattern. This class diagram promotes loose coupling because the subject is tied to observer. Both of them are interfaces. Okay. So let's understand the meaning of all these terms, what these terms mean. So this subject is basically one who registers the observers, removes the observer, and notifies the observer when an event has happened. Observer has an update method which can be called whenever the subject wants to notify an observer. Okay. And similarly, the concrete observer and concrete subject are the implementations of two. So let's take some examples. Okay, so if let's take a very naive example. Let's say subject are crackers and somebody is hearing those crackers. Okay, so somebody is bursting and somebody is hearing. So the one who is hearing the bursting crackers is an observer, and the crackers are the subject which are producing the sound. And whenever that sound is produced, all the observers are notified. And we can register new observers, we can remove observers. So this can be simulated by, let's say, somebody don't want to listen to crackers, so they will close their ears by their fingers. So this is equivalent to removing an observer. Somebody is closing their ears, that means an observer is removed. He is no longer getting updates from us. And somebody is opening their ears again, that is equivalent to registering an observer. Okay, that was a very naive example. Better example will be shares office or a stock exchange is there, and observers are the shareholders. So whenever the price of a share increases by 10% or more, the stock exchange will be notifying all the shareholders. Okay, so this is a better example, and we have written our code around this example only. So this is a subject class, which is basically an interface. It is having register observer, which takes an observer and registers it. Remove observer, notify observers, notify all the observers who are registered with us about the share increase event. So observer basically having an update method, which is called whenever an observer is updated. So whenever a subject wants to update to notify an observer, that is, it wants to update the information of that observer, it will call the update method on that observer. Okay, so these were just the interfaces. Let's look at their implementations. So basically these are the implementations of that. So stock exchange is implementing subject. It is equivalent to the concrete subject which we saw in our class diagram. It is maintaining an array list of observers. So in our class diagram, what we saw was subject is associated with an observer, not a concrete observer. So here you can see subject is maintaining an array list of observers, not concrete observers. So this is promoting loose coupling. That is, subject is dependent on an abstraction, not the concrete class, which is good because the abstraction, the concrete classes can change, but the abstraction will remain same. So it will always, whatever is implementing my observer must have an update method. I don't care about how you implement it. Your implementation can change. Okay, so, and that is there can be a another concrete observer, implementing the same observer, and we can still support it. Okay, so let's look at this stock exchange now. So it is basically creating a new array list. So these are just attributes and constructors. How we subscribe and unsubscribe new observers. To register an observer, we add it to our array list. To remove it, we remove it from our array list. To notify all the observers, we iterate over our array list and fetch the observers one by one and call update method on them. Okay, so in a moment we will see how this update method will look like. It is basically a setter for the share price attribute of that observer, which that observer has. So share price attribute is basically used as an information of the shares price which our observer currently has. So our observers knows that share price is this, so it will be updated only if there is a 10% or more increase. So whenever this method is called, price change by more than 10%, we will notify all the observers, and whenever this price changes, this is automatically called. So this method will be automatically called and all observers will be automatically notified. But so this is somehow called. We don't bother about how it will be called, but it is somehow called. Okay, in our observer, this is out of the scope of our observer design pattern, so this will be called somehow. That is, the event is created somehow. Observer design pattern deals with just when the event is created, we notify our observers. Okay, so here is a simple setter for our attribute share price. We set the share price, and to simulate the price change by more than 10% event, we let that occur here. Let that event occur here. That is, we call this method deliberately. So whenever we want to set the share price by some new share price, we will call this method. So this will not happen in actual code. Actual code will call only when 10% increase is there, but we are just calling each time we are setting the share price, just to simulate the behavior, just to see how everybody is getting notified on all. So this is not the actual code. Okay, I think you got it. So now let's look at the customer class, which is our concrete observer. It is having a share price attribute. It is having a stock exchange attribute. So whenever a customer is created, that is, its constructor is called, it will be provided a stock exchange to register to. So it will update its attribute by that, and in the next line it is registering itself to that stock exchange. So it will call register observer method on that stock exchange, and it will pass itself as an argument. That is, it is saying that please register me as your observer. Once it is registered, here is its update method, which will be called by the subject. So whenever this notify observer is there, whenever we want to notify the observers, we will call their update method. So observer.update share price, and whenever this update method is called, first thing we do is we update our attribute share price. This is done, and then we print, hooray, my shares is ups. So share price is increasing. This is printing this, and we are calling a method inform grandparents. So I'm trying to inform my grandparents that the share price is increased, and there can be an implementation. So what is must is all the observers must implement this update method. They can have their own implementations of this update, but they must implement this update method. So one can inform the grandparents, other can have maybe inform parents, other can inform uncle, or somebody can do nothing, somebody can not even print this thing, and they can have their own implementations. But our subject is knowing only about this observer, and that this observer is having update method, The concrete observer can do whatever it wants in the update method, but it must implement this update method. That's the thing. Okay, and this concrete observer, as you see, is having a concrete subject as a subject. So here we are having a subject in this concrete observer. So it will be instantiated by some actual subject. So that's the thing. So concrete subject, that is. So thank you, friends.